So today we're going to look at the relationship of congruent chords. So congruent chords, if two chords of a circle are equidistant from the center, they are congruent. So if we have that they are equidistant away, that means that AB, which is a chord, is going to be congruent to the length of CD. It also works the other way. If two chords are congruent, then they are equidistant from the center. Also remember, if we draw in these little lines and I extend them, this makes a radius, which is also going to bisect our chords into two congruent parts. So let's use that information to solve some problems. So in our first problem, we are given that circle P and PQ is congruent to PR, which means that these chords are now going to be congruent. So AB is going to be equal to CD. So we have 32 plus 4x is equal to 10 minus 7x. As we solve, we get 22 equals negative 11x, so x is negative 2. Then we need to find AB, so we are going to substitute back in. So we get 32 plus 4 times negative 2, which gives us a length of 24. In number 2, we have circle R. We know that SR is congruent to RT. We know that FE is x squared minus 10, and we know that HT is x plus 7. So remember that we also said if I extend this line, it's a radius, so it bisects the chord, so both pieces of the chord are x plus 7. This comes from yesterday's information. So we know then that x squared minus 10 is equal to 2 times x plus 7. So we get x squared minus 10 is equal to 2x plus 14. X squared minus 2x minus 24 is equal to 0. So we need to find numbers that multiply to negative 24 and add to negative 2. So we have x minus 6 and x plus 4 equals 0. When we switch our signs, x is 6 and x is negative 4. In this case, both solutions are going to work, so we would keep both numbers. So now to find GH, we know that GH is the same as FE. So GH is equal to 2 times 6 plus 7, which is 26. And we also know it's equal to 2 times negative 4 plus 7, which is 6. So because both x's work, there are two lengths for GH depending on what our x value is. Number 3, in circle O, PA is x plus 9. CD, this whole length, is 5x minus 3. And OP is 12. As well as OQ is 12. So those are equidistant away from the center. So if I use x plus 9 also up here because our chord was bisected, we know that 2 times x plus 9 is equal to 5x minus 3. So we get 2x plus 18 is equal to 5x minus 3. 3x is equal to 21, so x is 7. Then to find AB, AB is equal to 2 times 7 plus 9, which gets us a length of 32. So to find the radius of circle O, we now know that 7 is x, so we know that AP is 16 because 7 plus 9 is 16. If we draw in a radius from O to A, we have a right triangle. So we can do Pythagorean theorem to find our radius. So x squared equals 16 squared plus 12 squared. X squared is equal to 400. So x is 20, which means our radius of the circle is 20. Then using the radius, we can find our area and circumference. So remember that area is pi r squared, so we have pi 20 squared, which gets us 400 pi units squared. For circumference, that is equal to 2 pi r, so we have 2 pi times 20, which would get us 40 pi units. Number 4, we are given circle N, and we know that OA is congruent to GS. So because the chords are congruent, that means they're equidistant away from the center. So using the coordinates, we can solve for x. So remember, our distance formula is x2 minus x1 squared plus y2 minus y1 squared. So we're going to do distance formula with the 2 points together. So we're going to do that. Rn needs to equal NE. So when we do the distance with Rn, we have x minus 7 squared plus negative 1 minus 7 squared equal to, and we're going to do the other coordinate as well. So we have x minus negative 5 squared plus negative 1 minus negative 9 squared. So as we simplify this, we have x minus 7 squared plus negative 8 squared is equal to x plus 5 squared plus 8 squared. So we have to remember to multiply out the x minus 7 squared, so we get x squared minus 7x plus 49 plus 64, and we square the negative 8 equals x squared plus 5x plus 5x plus 25 plus 64 when we square both sides. So to get rid of our square root, we're going to square both sides. So when we simplify this, we get x squared minus 14x. We can add the 49 and the 64 together to get 113 is equal to x squared plus 10x plus 89. So there's an x squared on both sides, so those cancel out. So we have negative 14x plus 113 is equal to 10x plus 89. We can combine our x's on one side, so we get 24x. Combine our number on the other side, and we get 24. So we divide, x equal to 1. In number 5, given circle S, OS is congruent to SE, which means that the chords are the same distance away from the center. So we know that TE is 3x plus 1, ER is 4x plus y, and the whole other segment, NM, is 2x minus 5y plus 2. So we know that the entire chords are congruent, so we can say 2x minus 5y plus 2 is equal to 3x plus 1 plus 4x plus y. So we're going to get x and y to one side and numbers to the other. So we have 2x minus 5y plus 2 equals 7x plus y plus 1. We can subtract over the 7x and the y, so we get negative 5x minus 6y, subtract 2 to the other side, so we have equal to negative 1. Then we also know that SE, if we extend it to make it a radius, it bisects the chord PR, so we have 3x plus 1 is equal to 4x plus y. So if we move x's to one side and numbers to the other, we get negative x minus y is equal to negative 1. So now that we have two equations with x and y's, we're going to do a system. So negative 5x minus 6y is equal to negative 1. Negative x minus y is equal to negative 1. So we can multiply the second equation by negative 5. And we get negative 5x minus 6y equals negative 1. And 5x plus 5y equals 5. We add straight down, we get negative y is equal to 4 because the x's cancel out. Divide by negative 1, and y is negative 4. And we have to substitute in to get our other value. So we have negative x minus negative 4 equals negative 1. Negative x plus 4 is equal to negative 1. Negative x equal to negative 5. So x is positive 5. So we have 5, negative 4. In number 6, we're given circle O, and we are told that the chord AB is congruent to chord CD. We know that QP is x squared plus 3x. PR is 5x plus 35, and CD is 6x minus 2. So because the chords are congruent, that means they're equidistant away from the center. So we have x squared plus 3x equal to 5x plus 35. Move our variable over, so x squared minus 2x minus 35 equals 0. So we need two numbers that multiply to negative 35 and add to negative 2. X minus 7 and x plus 5 equals 0. When we switch our signs, x is 7 and x is negative 5. In this case, negative 5 will not work because it will give us negative lengths for CD. Then we need to find AQ. So AQ is half of the chord. So we know that AQ then is going to be equal to half of CD. So we have half of 6 times 7 minus 2, which is half of 40. So AQ is going to be equal to 20.